The challenge is that space is unimaginably vast, and the laws of physics prevent us from moving or communicating faster than the speed of light. That restriction means only the nearest stars to our Sun could realistically be explored within a human lifetime, even with robotic probes. Among those, the best candidates are stars that closely resemble our Sun in size and temperature. Such stars live long enough and remain stable enough to allow complex life to develop. The overwhelming brightness of stars. Observing an Earth-like exoplanet separately from the star it is orbiting around is a major challenge. Even in the best possible scenario, the star is 1,000,000 times brighter than the planet. If the two objects are blurred together, there is no hope of detecting the planet. Optics theory says that the best resolution one can get in telescope images depends on the size of the telescope and the wavelength of the observed light. Planets with liquid water give off the most light at wavelengths around 10 microns, the width of a thin human hair, and 20 times the typical wavelength of visible light. At this wavelength, a telescope needs to collect light over a distance of at least 20 meters to have enough resolution to separate the Earth from the Sun at a distance of 30 light-years. To resolve nearby Earth-like exoplanets, a new telescope design that is rectangular rather than circular may be necessary, according to a new study that explores what the next great space telescope might look like. We show that it is possible to find nearby, Earth-like planets orbiting Sun-like stars with a telescope that is about the same size as the James Webb Space Telescope, JWST, operating at roughly the same infrared wavelength as JWST, with a mirror that is a 1 by 20 meter, 65.6 by 3.3 foot, rectangle instead of a circle 6.5 meters, 21.3 feet in diameter. Heidi Newberg, who is a professor of astrophysics at Rensselaer Polytechnic Institute in New York, wrote in an editorial about the concept. Top of the National Academy's Astronomy and Astrophysics Decadal Survey is a new space telescope that is capable of imaging Earth-sized planets in the habitable zone of Sun-like stars. Although no design has been settled upon yet, a roundish mirror with a minimum aperture of 26 feet, 8 meters, has been mooted. This is 5 feet, 1.5 meters, larger than the current largest orbiting observatory, the JWST.